Hi, I'm Chris, and I'm presenting my product called Flip. I'm currently in first year studying design engineering at Imperial College, and Flip was my A-level project. Flip is a striking, sustainable and minimalist clock. The hands move in a very unique way by jumping and flipping to the next position at each interval. The clock has an hour hand, which flips every quarter hour, and a minute hand, which flips every minute. The clock also has a soft light in the centre, which changes from a cool light to a warm light throughout the day, adding to the atmosphere of the room. When I started this project, I wanted to create a product that had an aesthetic appeal, but allowed me to learn and apply mechanics, electronics and programming. I wanted Flip to be a centrepiece in any room, so I knew that the hands had to move in a way that would make someone watching wonder how it works. The reason why I chose flipping is so there's a satisfying click. The complex mechanism that I designed is hidden under the face, making the outcome seem simple but very mysterious. The concept behind the mechanism is that if a magnet rotates underneath the face, the magnet on top will also rotate. This is a simple concept, but was very challenging to pull off, especially for a clock. The mechanism consists of three subsystems. I will use a minute hand as an example. The first system is to rotate a disc exactly 6 degrees every minute. To achieve this, a cheap DC motor drives the disc using gears. This ratio is not important as long as it is not too fast or too slow and has enough torque. Then, around the disc are holes spaced at 6-degree intervals. These represent each of the 60 positions for the minute hand. Then, on one side of the disc is an LED, and on the other a light dependent resistor. So, if the LDR, which stands for light dependent resistor, detects light, it is in the right position for the minute hand and needs to stop. And if the light is blocked, it needs to continue moving. I feed this input into an Arduino, which then controls the motor, and with some code I made the system work. The next system rotates the magnet around the radial axis. To do this, I use the rack and pinion mechanism. The pinion is fixed to the same axle as a magnet and is engaged with a rack curved round the whole face to make a circle. Then, using maths, I worked out a ratio that meant in one complete loop, the pinion would rotate 180 degrees 60 times. This was hard as I had many constraints because I had to make it fit within my design. The third system is all in the programming and electronics. This system oversees the time intervals. For timing, I'm using the built-in quartz chip on the Arduino, but in future models I'll link this to the radio, making it more accurate. For demonstration purposes, I've changed the code so that the hand flips more frequency. I designed this whole mechanism so it could be easily and cheaply made. Everything is either a cheap stock component or is laser cut. I chose two materials. Acrylic was used for the structural components, as it is cheap and rigid, and acetal was used for the mechanical components, as it is strong and has a low coefficient of friction. The design of the clock was inspired by a grandfather clock, but with a modern touch to it. The clock has the face, and then what looks like a pendant. I chose the material to give a traditional feel to it, using oak for the face and aluminium for the rod. The rod functions as a user interface for the light by sensing touch with capacitance. It also carries cables inside to the oak pendant, which holds electronics and an interface to change the time. I first started off with these designs and chose this as my favourite clock design. I then did a rough sketch and set some dimensional constraints. Next, I came up with the concepts on how to make the hand flip. I originally chose to use electromagnets to make the hand flip, but after testing, I realised the power needed was too high and a mechanical solution would be better. That's when I came up with the concept of a rotating magnet under the face. I started making simple straight prototypes on CAD and cut them out on the laser cutter. It took 5 iterations until I got this working reliably. Then I moved on to a circular design, which is harder. Then I made tests for the laser, LDR and motor subsystem. Finally, I was ready to make a full-size working hour hand mechanism. This worked well and reliably with a few minor issues. You can see it working here. I then moved on and made the whole mechanism. I had to cram everything together to make sure it would fit into the mechanism. I then designed the final face. I did lots of planning on the process of manufacture, then I cut it out. Finally, I sanded and varnished the wood, and then assembled it. I've created a bill of materials for the clock and they come to a total around £90. If I scaled it up, I have guessed it would cost around £50. A large part of the price reduction is the wood, which cost me £30. The wood that I used was a kitchen worktop offcut, and I've actually talked to a local kitchen fitter and they said that they would be happy to work with me by supplying me with their offcuts and promoting me if they take a small percentage of the profit. Furthermore, the area needed fits perfectly into a common sink and hob cutouts. Also, the CNC means I can cut any wood. I could also offer a clock that uses your offcuts, so the clock matches the kitchen worktop, which people have actually said they find very appealing. After talking to potential clients and taking surveys, the price I'd sell the clock is for between £200 to £300. On a personal note, I've had a lot of obstacles and I've learned so much during the whole thing, and I'm really proud of the final result. Thank you very much for watching.